All right, 9.3, this is our last section. I started today with equations of lines because we are going to be finding the slope, the actual slope, which we did a little bit before already, and then we're also going to be taking that slope and writing it as an equation of a line. And some of the problems ask us to write it in point-slope form, some of them ask us to write them in slope-intercept form, and so we just have to kind of make sure that we read the directions and make our end result exactly what it is they're looking for. On this first section, it says find the slope of the tangent line at the given value. We did this again in our first section, or our second section, I think that we did, where we found the derivative and then plugged in the value, and that's what's going on here. So I need to find the derivative. It's a review of what we did yesterday. And in fact, what I'm going to have you guys do is go ahead and find the derivative of number one. I'm going to pause. I'm going to let you go through that process. If you need to look back at your notes from yesterday, go for it. And then we'll regroup and get together and do the plug-in when we're done. So this is not something new. This is something that we talked about yesterday. Once you find your derivative, and in my case, I ended up with negative 2 over x minus 1 quantity squared. I hope we all agree on that. In order to find our slope, I just have to plug in the 3. So it looks like negative 2 over 3 minus 1 quantity squared, or negative 2 over 4, or negative 1/2. And again, this is the slope. It is the slope of the line tangent to this function at the value x equals 3. And so if I were to graph this function, it's an inverse function. It's one of those that they sort of look like this kind of thing. You did those in Algebra 2. And at 3, I know that this is dropping fairly slowly. So let's go through and kind of do the same thing on the next one. Find our slope, plug in our value. Again, once you take your limit, that means once you put the 0 in for h, you can drop that part of it and drop the limit. That part's done. Sometimes people I don't know when I'm supposed to keep putting it and when I'm not. Keep writing the limit until you take the limit. And then when you take the limit, you're done. And so it's just kind of working through. And I'm not always like a super picky person about work, but again, it is important that you write the limit down until you take the limit. It changes the value of the problem if you don't. It's not equal if you don't have that. So keep that in throughout. And now I'm going to evaluate. Again, it's at x equals 3. So dy dx at x equals 3. That's 2 times 3 plus 8, or 14. That is the slope of the tangent line to this function at 3. That's my slope. That tells me at 3, if I were to look at the graph of this parabola, that's what it is. At 3, it is rising fast. 14 is a pretty steep slope. It's positive. That means my graph is increasing or rising at that location. We're not going to do number 3 again. We're going to have shortcuts. We'll be able to do the shortcuts when we get to problems like number 3. I don't want to take the time to go through that because especially I want to make sure you get time to review for your test, which is tomorrow. But we will go through problem number 4 in the same way. And again, it's good practice for doing our derivatives. So I'm going to pause it again. We'll work through the problem and then we'll come back and evaluate the actual slope. Once I'm here, again, I need to evaluate. And it says evaluate at x equals 1 this time. How do I know? Because that's what it says right here. At x equals 1, so I just put that in. So I go ahead and do dy dx at x equals 1 is 1 over the square root of 2 times 1 plus 1, which is 1 over the square root of 3, I believe. Or better than that, the square root of 3 over 3, when I rationalize the denominator. So again, that is my slope. On the next side, we're going to take it just one step further. We're going to take the slope and the point that they give us, and we're actually going to be ending with the equation. So we're looking for the equation of the tangent line. What I had talked about is, and I'm going to use this space here, like especially if I think about what problem number 2 looks like when I graph number 2, okay? This isn't this guy. Problem number 2, if I were to graph number 2, it's a parabola. If I find the location at 3, it's going to be a point on here somewhere. I'm just approximating. Okay, this isn't exact, but let's say this is x equals 3. There is a line that is the tangent line that hits at that spot, and this line has a slope of 14. What I'm going to do now is not just find the slope, find the actual equation of the tangent line. So that's where we go and use the point slope form or the slope intercept form depending on the problem. So here we are. This one says slope intercept form, but I'm going to use point slope form to get there. Remember, slope intercept form is y equals mx plus b. Point slope form that I'm going to use to get there is y minus y1 equals slope times x minus x1. So those are the two things that I'm going to be working with. When I do point slope form, there's no like trickery or like anything mystery, deceiving. I need a point and a slope to get point slope form written, hence the name point slope form. I have a point. Right here is the point. Now I need the slope. The slope comes from the first derivative, so we're going to go through that process again. Let's skip 5. Again, I don't like the x squared in the bottom. We'll jump on to 6. Right here is the point. That is the x1, y1 part of this. When I find the derivative, that will help me find the slope. So f prime of x is the limit as h approaches 0 of f of x plus h minus f of x all over h. I need to simplify, and so I multiply the first fraction. Oops, that's a 2 there, sorry. The first fraction top and bottom by the denominator of the second, and the second fraction top and bottom by the denominator of the first. I put it all over the new denominator. And everything over h. Now, when I did this multiplying, I multiplied -1 times x plus h plus 2. That's how I got minus x minus h minus 2. Don't forget to distribute the negative throughout. And again, at this point, I know I'm okay. I know I'm in good shape. I know I did all right. If everything on the top that does not contain an H cancels out and things are looking good. This bottom is H over 1, so I'm going to multiply by 1 over H on the top and on the bottom, and that cancels out the H as well. Watch out though, there's a negative in front of that H, so I still have a negative 1 left on the top. I don't want to forget that. I don't want to lose that negative 1 that's attached to that H. So now I have, still didn't take the limit, that's why I'm still writing it, negative 1 on top over all of this bottom. And then I can take my limit, zeroes out the H term. Now that I've taken the limit, I drop it. I don't have to write the limit anymore. And dy dx is negative 1 over x plus 2 quantity squared. All right, I've got the point. Got the point. The point was given at the top. Now I need the slope. So I'm going to do dy dx at x equals 1. Where did the 1 come from? In the point. That's the x value in the point. Right. So that's what I'm going to be using in order to find my slope. When I do that, I get negative 1 over 1 plus 2 squared, or negative 1 over 9. I'm going to bring this whole problem over to this other side here just because I kind of ran out of space. I wrote a little bit big. And now I want to put it all together because I need to have the equation of a line. So right now, I have my slope. I have my point. I go ahead and put it together in my point slope form. Y minus y1 equals the slope times x minus x1. These directions said write it in slope-intercept form, so now I have to do that little bit of manipulating that we did before. If it says write it in point-slope form, I could stop here, and I just distribute this. And then I'll add the 1/3 over to the other side. And I believe that's 4/9 when I do that fraction adding. This is my final answer. All right, we're only going to do one more. And actually, I'm going to have you do the derivative of the one more. Would you rather do 7 or 8? 8? Okay. Again, so I've got my slope. I don't want you to think that it's always going to be one that you plug in. Please make sure when you're doing your homework, you look at your point. You plug in the x of the point. So if the point is 3, 0, I'd plug in 3 for my x when I'm finding my slope. This case, or in all of these, it happened to be 1. So that's why I plugged in 1, or the 2 that we did happen to be 1. All right, so now I've got my information that I need. I need a point. Check. I need a slope. Check. I put it together in my line. I'm going to bring it over here. This is not for this problem. It is y minus y1. That's this guy. That's y1. It's my x1. Equals my slope times x minus x1. Y minus 3 is 2/3 x minus 2/3. And when I add the 3 over, I believe 7/3, but I wrote 7/7, but I meant 7/3, and that should be my equation. Okay, so that's the last of it. All right, homework. In 9-3, all I want you to do is 39 through 44 evens or odds. That means you do 3 problems total. 39 to 44 evens or odds, so 3 problems total there. But you also do have a review. Oops, I should stop this one.